Well, welcome to lesson 1.1 of Algebra 2, Properties of Real Numbers. Now understand the purpose of this video lecture is for you to pause and rewind and rewatch this video as much as you need or as little as you need to master the lesson for each section. So today's lesson is Properties of Real Numbers. Okay, what you'll learn, and you'll see this on every set of notes we have, is we're going to learn how to graph, real numbers, and we're going to learn how to identify and use the properties of real numbers. So moving on. Okay, algebra deals with operations and relations amongst the numbers, real and imaginary. But here's what we need to know about all real numbers. We'll talk about imaginary numbers in chapter 5. So the subset of real numbers, and you can follow along. Natural numbers are just the numbers we use in counting, not including zeros. So think of your fingers. 1, 2, 3, 4. Whole numbers are all natural numbers plus the inclusion of 0. Okay. Integers are all whole numbers and their opposite. Okay. So all natural numbers, 0, and all their opposite are the negative integers. Okay, each negative integer is the opposite of a positive integer. Rational numbers are basically are all numbers that can be written as a quotient of two integers. So an integer over another integer. Each quotient must have a non-zero denominator. Okay. And then finally, irrational numbers. The examples in the book are square root of 2, pi, square root of 7, some non-repeating decimal point. Irrational numbers are numbers that cannot be written as quotients of integers, and their decimal representation neither terminates nor repeats. Okay, so let's kind of look at that in a diagram. So you'll see in this diagram you have real numbers. Everything in this diagram right here is real numbers. So everything right here is a real number. Okay? Real numbers are broken down into rational numbers on the left, okay, and irrational numbers on the right. Remember, irrational numbers are numbers that can't be written as a quotient of rational numbers that have non-repeating decimal points and also radical signs. Rational numbers, looking at the top, follow along with the blue pen, our examples are right there. Fractions, a decimal point, positive or negative. Integers are positive and negative whole numbers. Whole numbers are all positive natural numbers and 0, and then natural numbers. Again, so that's your diagram of how numbers or real numbers are broken down. Okay, this example, the set of whole numbers is a subset of integers, which is a subset of all rational numbers. The set of rational numbers and the set of irrational numbers do not intersect. The rational numbers and irrational numbers form the set of real numbers. So all these points up here basically can be represented in a number line. So let's just look at our examples and see how we can get along with this. Okay, recreation. Many mathematical relationships involving variables are related to amusement parks. Which set of numbers best describes the value for each variable? Okay, in part A, the question is talking about the cost C in dollars and the admissions for N people. Well, the cost would be a rational number because it could be a fraction. It could be 725 as an example. And the number of people would be a whole number, okay? Because you can't have 0 people in this example, and you can't have negative numbers of people. And, of course, you cannot have a fraction of people. So that's part A. Part B. The maximum speed S in meters per second on the roller coaster and height h meters. Okay, well the speed, we can't see the diagram right here, but in your book you can, is written with a radical sign, with the square root. So since the speed is calculated using the square root it is irrational unless, of course, h is the square of a rational number. The h, of course, is a rational number. The park's profit or loss, P in dollars, for each week, W of the year. Well, the week is a natural number between 1 and 52. And the profit is a rational number because, again, money can be fractions and it can be a negative or a positive. Okay, we feel good. So here's our example in the book. The number R is the ratio of number of adult tickets sold to the number of children tickets sold. The number C is the average cost per family per tickets. Which set or sets describes what R and C are? Well, we read R is a ratio. So a ratio, if we remember from Algebra 1, is something over something else. So adult tickets over children tickets. So that has to be a rational number because both of the number of adult tickets and the number of children tickets would have to be a natural number. So R is a ratio. Okay, the number C is the average cost per family per ticket. Well, we know right now money has to be irrational. Okay, so the answer by really process of elimination is C. Both of them have to be rational. Okay, moving on to the next example. Graph numbers on a number line. So the question's asking us to graph negative 3 halves, 1.7 with the repeating sign, and the square root of 5. Okay, let's just look at the number line. We know negative 3 halves is the same as negative 1.5, so it's going to be between negative 1 and negative 2. So right there is negative 3 halves. Okay, 1.7 repeating. So we know that's got to be between 1 and 7, or sorry, 1 and 2, closer to 2, repeating. So that's pretty easy to graph on the number line. And the last one is the square root of 5. Well, the square root of 4 is 2, and the square root of 9 is 3, so we know the square root of 5 has got to be closer to 2. We could put it in a calculator and we'd find out it's about 2.2. So if we graph that on a number line, it'd be greater than 2 and less than 3. Again, some of this hopefully is redundant for us, and that's okay. We've got time. So next example, which is the most reasonable graph of the numbers, the negative square root of 2, 0.3 repeating, and negative 2 and 1/4? Well, let's start with negative 2 and 1/4. Well, negative 2 and 1/4 has got to be between negative 3 and negative 2 and closer to 2. So A is out. Okay. B would work, C would work, and D would work. Okay, 0.33 or 0.3 repeating, so that's going to be between 0 and 1, closer to 0. So we don't even need to look at A anymore. Okay, so we're going to just skip it. Go to B. Well, that falls correctly between 0 and 1, closer to 0. This does not fall because that is on the negative side, so that one's out. And this one falls in the right spot. Okay, so looking at it, we know A's out, and we know C's out. And the last one we need to compare is the negative square root of 2. Well, the square root of 2, if we plug it in a calculator, is about 1.4. Okay, so the negative square root of 2 would be negative 1.4. So we know that on the number line, that's got to fall between negative 1 and negative 2. So there's negative 1, there's negative 2. That falls in between. So the answer would have to be B. Okay, moving on. If A and B are real numbers, then one of these things has to be true. A equals B, A is less than B or A is greater than B. There are several ways to prove that A could be less than B. One is the graph of A is to the left of the graph of B on a number line. So you would have a number line, you would have an A and a B, so you could say A is less than B. The positive number can be added to A to get to B. So A plus some random number equals B. And then B minus A is a positive number. So the next example, let's just compare. All right, the square root, the negative square root of 0.25 and the negative square root of 0.01. Well, negative square root of 0.25 is negative 0.05, and the negative square root of 0.01 is negative 0.1. Okay, so we know which one's closer to 0. Well, this one is. So we can put the alligator that way. Easy stuff to put on one. So which statement is true? Well, let's just get our handy dandy calculator out. And let's hit the square root of 0.08. Find out what that is. We find out the square root of 0.08 was 0.2828. So the negative square root of 0.08 would be negative 0.2828. Okay? We can put the in the calculator over here, negative square root of 0.1. So let's put that in our calculator. Square root 0.1. We get 0.3162. 0.3162. So which one is closer to 0? Well, the negative 0.28, so we can say that one is greater. So the answer would be B. Okay, 1.1, objective 2. The opposite or additive inverse of any number A is negative A, and the sum of those would be 0. The reciprocal or the multiplicative inverse of any non-number 0 of A is 1 over A, and their product is always 1. So finding the inverses, okay? Let's just follow along. If I'm worried about negative 3.2, well, what's the opposite of negative 3.2? 3.2. What is the reciprocal? Well, the reciprocal is 1 over negative 3.2, which we could say is negative 10 over 32, which we could divide by 2, simplify it. We just multiplied the top and bottom by 10. Now we multiply or divide both sides by 2, so it's going to be negative 5 over 16. Okay, B, 3/5. So, what is the opposite of 3/5? Negative 3/5. What's the reciprocal of 3/5? Just flip it, right? Remember, reciprocal, 5 over 3. Easy stuff. Find the opposite and the reciprocal of 400. Well, let's look at 400. What's the opposite of 400? Negative 400. What's the reciprocal of 400? 1 over 400. 4b, find the opposite and the reciprocal of 4 1/5. Okay. So, well, 4 1/5. The opposite is just negative 4 1/5. Okay, the reciprocal. First, let's set up the fraction. 5 times 4 is 20. 20 plus 1 is 21. 21 over 5. So the reciprocal is just 5 over 21. So the answer would be C. Okay, the next two. I'll let you work these on your own for a second. So find the opposite and the reciprocal of negative 0.002 and find the opposite and reciprocal of negative 4/5. We'll pause it here and let you try to find it. Okay, well, if our initial number is negative 0.002, the opposite, you just flip the sign, is 0.002. Okay, so now we just got to find the reciprocal of that. So it's just that over 1, right? So the reciprocal would be 1 over 0.002. Well, what would I multiply that top and the bottom by to get rid of the, make the denominator 0. Well, if I multiply the top and bottom by 1,000, just to move the decimal points, I would get 1,000 over 2, which will reduce to 500. So that was the reciprocal. That is the opposite. So hopefully that was a negative number, so that would be negative. So the answer would be B. Okay, find the opposite and the reciprocal of negative 4/5. So negative 4/5. Sorry, 4/9. So the opposite would just be 4/9. The reciprocal we would just flip, which would be 9 over 4. And again, that's a negative. Okay, going on. Let's just go over some of the brief properties of real numbers. Okay, the property of closures is A plus B is a real number. A times B is a real number. Okay, so you see up here it says let A, B, and C represent real numbers. Commutative, A plus B is the same as B plus A. A times B is the same as B times A. Associative, A plus B in parentheses plus C is the same thing as A plus B plus C in parentheses. So A, B parentheses times C is the same as A times B, C parentheses. Identity, A plus 0 is equal to A, and 0 plus A is equal to A. A times 1 is A, 1 times A is A. The inverse, okay, that's just the opposite. A plus negative A is 0, and the reciprocal, A times 1 over A is 1, as long as A is not 0. And then distributive property, A in parentheses of B plus C is the same thing as A times B, A times C. So distributive property, inverse, identity, so on and so forth. Okay, make sure you understand that, and just that should be again a refresher for you. Which property is illustrated? 6 plus negative 6 equals 0. That is nothing more than the inverse property of addition. Just saying the opposite plus a number is 0. Okay, part B, negative 4 times 1 minus 2 is the same thing as negative 4 minus 2. That's the identity property. Remember the identity property. Let's go back. Identity property is anything times 1 is itself. Okay. Which property is illustrated here? 3 plus 0 minus 5 is the same as 3 minus 5. Well, that'd be the identity property of addition. Okay, what about this one? Negative 5 plus in parentheses 2 plus negative 3 is the same as in parentheses negative 5 plus 2 plus in parentheses negative 3. Okay, if you're not sure, look back. That looks like it's the associative property. So it should be the associative property. Okay. The last point in 1.1. The absolute value of a real number is its distance from 0 on the number line. So finding the absolute value. Find the absolute value of negative 4. Find the absolute value of 0. And find the absolute value of negative 1 times negative 2. Okay, so anytime you have groupings inside of the absolute values signs, you're going to simplify first. So we're just going to graph negative 4, 0, and 2 on the number line. So negative 4 is 1, 2, 3, 4 units away from 0. So the absolute value of negative 4 is 4. The absolute value of 0 is 0. And the absolute value of 2 is 2. So simplify. The absolute value of negative 10, the absolute value of 1.5, and the absolute value of 0 minus 3. So let's break those down real quick. So the absolute value of negative 10 would just be 10. The absolute value of 1.5 would just be 1.5. The absolute value of 0 minus 3 would be the absolute value of negative 3, which would be 3. So it should be 10, 1.5, and 3. So the answer should be C. Okay, again, absolute values should always be positive numbers. Critical thinking. For what value x does the absolute value of x equal negative x? Okay, I just told you it can't be a negative value. So let's think about that. So negative 0 would be the only possible answer. Is the same thing as positive 0, which is the same thing as 0. So the answer would be D. Alright, hopefully that was a quick brief overview of 1.1 for you. Feel free to look that over. Now it's time for you to go do your homework, whatever is assigned in RenWeb for you for section 1.1.